Hi, we're going to do here a few lectures on Matlab, and I'm going to cover just some of the basic commands so that we will be able to perform simple operations on arrays and matrices, learn input and output, use this in things like differentiation, integration, and then eventually we will get into some more advanced applications, namely the fast Fourier transform methods, so we can learn how to do more efficient data processing. And I also would like to cover much more on how to do graphics. So I'll switch between the screen and also the Matlab workspace itself. So if you look here, we are going to discuss the input-output commands in this first lecture. So I'm going just to focus on this topic here. Um, all right, so basically the idea is that we wanted to be familiar with the basic MATLAB commands and to efficiently um, learn how to make graphics, and then finally to do work on data acquisition signal processing. So let's start here by, if we're going to write a program, first thing we got to do is clear the workspace in the program. So we're going to use this command clear all, and the command close all for anything that was open before we started. And then we also clear the screen by CLC, which basically will clear the entire screen. Now, in order for us to do input and output, what we have in mind here is that we would have a possibility of ways to input the data. So we can input the data either directly on the screen using an input command, or we can input the data from a file. And the file could be in the formatted file, for example, obtained in the form of an Excel worksheet. So let me just kind of review here what the different commands are for inputting the data. First command that you can see here is CSV read, comma separated variable read, and then basically we enclose the file name in parentheses, as you can see here, and that will read any file that has commas in between. In general, which a better way is to just use this command load, and then in between quotation mark we put the file name where we're going to load the data. The corresponding commands for writing is either CSV write, the same style as CVS read here, and then we enclose A. A is the matrix that we want to write, or the column vector that we want to write, and then finally we can also use the print command to print especially PostScript files that contain the graphics. So that's kind of some of the basic ideas in inputting the data. Let's see how we're going to input the data also from the screen, and in a very general way that has formatting. As you can see from those, we load whatever we have, which is very simple, and we don't worry about formatting. But in some cases, we want to load the data into a matrix with a specific format. So let's see how this works. Okay, before we get there, I wanted to review some useful string commands, because strings are important in writing out the results of our computations. One command converts a variable to a string, which is num2 string, num2 str, and then x is either a scalar or it could be a vector. So this command actually converts the scalar or vector to a string that we can print. That's the idea, is to print this string instead of printing a variable. We cannot print the variable directly. Then we print a string that represents the variable or is in the form of the variable that we can read. The other backwards way of doing it is we can convert the string to number. So we put the string here and it's converted. The more general commands for reading formatted files that contain strings is string scan format file. So we scan the file for strings. So S is a string, scan, and then F is a file. So string scan file, and that's a way to read from the file the strings directly. And the corresponding printing is a string print file. So an example here is that I have a vector that I created by making a linear space command. Lin space, the beginning is 0, the end is 2 pi, and then I need 100 points in between. And the apostrophe, it means transpose. So the lin space give you a row vector that is 100 elements long. If you do this apostrophe, then you take the transpose of that vector. And then you put C1 is equal to 2, C2 is equal to -3, and then you compute function y directly by the sign of the vector x, meaning that every element of sign x is computed at these intervals between 0 and 1, between 0 and 2 pi. And then the result is multiplied by a scalar. So when we multiply by a scalar, we just use the star command. So there's no dot in front of the star. We'll get into this dot business a little bit later. So if you have a scalar, you just multiply by normal star, and therefore the y is a vector, also a vector of the same length as the vector x. So x was 100 elements long, y will be 100. Now I can create a string s that is made of a number of things. First one here, first element of the string. So this is a vector also that is called s, but the members of this vector or the elements are just strings. So the first one is num to string c1. It means that it's going to take 2, c1 is 2, so it's going to put 2 here and then convert it to a string that looks like the letter 2. And then in between quotation marks, you can put whatever you put in here will be printed as is. So it's just basically, it will print 2 instead of this variable. And then it will print times sine x plus, and then it will print -3 times cosine x. Meaning that when you print s, it will look like the form of the vector y. It's just looking like the form of the vector y. Next, I wanted to discuss a little bit about how to input data from the workspace browser and the variable editor. So another way is to input data from the screen, and then when you input data from the screen, you can store it in arrays and matrices. And you can go back and modify that from the workspace editor. So I'm going to pop here the Matlab workspace, and then you will see how this works. So let's say I have, as you can see here, I was working with a number of variables, and all of them, if you the workspace here, if you just click on if you click on the workspace, it shows you what I have been working with. So I've been working with an A, and the A has a value 1, 2, 3, 4, and it is actually a row vector, as you can see. And then answer is scalar, so it was just a scalar. And B is another row vector, and so on. Then if you go to other things, it shows you that del x is 1 time by 18 row vector, and it's a double precision, and so on. So let's say that I wanted to input additional data to x. Let's say I'm going to take x here, then I double click on it, and it's going to open what x is. So you can see x here, 70, 80, 90. So there's some data that I was inputting before, and this data is input in a row vector that has 19 elements, and each element is a particular temperature, let's say. So let's say I want to increase that, then I can just put simply 320 here, and then A is now has one additional input data that I included, and it's fine. It is just now, it says 1 times 20 double, so it's stored. I can close that variable, and then if I go back and then type here, like if you look here, I'm going to type A, then A is going to show the values that I put in there, but I wanted to look at X, so I'm going to type X here. Then X should give me columns 1 through 12, and then it gives me columns 13 through 20 because I included some more. So this is a different way to input the data through the workspace and the workspace editor. And these are summarized here on this slide, that you put in whatever data on the screen, and then it will store them. Like A is a matrix, and X is an array or a vector, and then you can access that and edit it if you want. So this is kind of a nice way to also get the input data. Here is a very simple computer program that we are going to review to show you how we would input the data from the screen, and then how we plot it before we even start working on the plots. So we have input variable, everything that has a percent, it means it is commented out, so it's not going to be computed, it's just comments. And then we will start having now our G is equal to 9.81, this is acceleration SI units, and I'm going to have a variable called T final, and this I'm going to input from the screen. So the command for it is input, and then if I put quotation marks here, this will be printed on the screen, which is enter the final time in seconds. And then the screen is going to wait for you to prompt, and as soon as you're ready, you input any number, then it will assign this number to T final. So T final becomes a number, and you can do calculations. So the calculations that we'll do are next, very simple, that we're going to take T final and divide it by 500, and then we're going to create an array of 501 time values from start to finish with a delta T. So this concept of array is that I can say T is an array, it's a row vector starting and then incrementing and then finish, T final. That's a nice way, which is remember that we had the linspace command that we reviewed before, and the linspace command is similar. So linspace is here, The length space is that the beginning and the end, and then the number of points. So this is kind of precise because you don't have to worry about the incrementation, how it goes to the end, because you have 100 points, it will generate 100 points. The corresponding method of doing array with this colon operator here is you put the initial and the interval and the final, and it gives you the vector. If you multiply the vector by a scalar, you don't use the dot operator. So you have v equals g, no dot operator, just a star times t. If if it were to be a vector, then we would have written it like this, g dot star t, and we'll come to that later, but right now it is just a scalar, so we're going to write it like here, and we will proceed with the values of the v. We have t and a v now are two variables. Each one is a vector. The same length is important. We can plot t versus v, and then we give it a label. We get an y label, and we get a graph out of that. The next commands are actually the last and more general commands for input-output, and these are when handling data in files. So we usually have a file, and the file is formatted, and then we will read it into matrices or vectors, and then we would write the results also on files if we want to look at the numbers. If we don't, then we usually put them in plots, which will be another topic we'll talk about. So the commands are summarized here. The first one is called file open, fopen, and you give it a file name that you want. So the file name is your own name for the file, and you give it a permission, and the permission string is R is for read, W is for write, and so on. So if you don't have a permission, then there's no problem. Then you don't have to worry about reading or write. It will be kind of default. Another command is opposite to this, is file close. So file close is you close the file with the identifier. The identifier file ID, generally we have 0 or 1 or 2. 0 for read, 1 for write, and 2 for error. So when you open the file, then you open it and you give it an ID, and then you can now scan. This is a formatted scan of the file. Formatted scan of the file. You give it the file ID, let's say 0, and then you give it a format string, which is either tell it that it is reading a string, or it is reading a variable, and the variable has a format, E format, for example, scientific notation format, or any general format. And the corresponding way for printing is f print f, and the file ID you print on the file ID, let's say 1, and then you give it the format that you want to print and the variable name that you want to print, and you continue format, variable name, and so on. So you can have each format corresponding to a variable, each format corresponding to the next variable, and so on. Same thing with the you could do file formatted print file with the format string and then the variable and so on. So it's either you put the ID or no ID. If you don't have a file ID, then it will print on the screen. If you have a file ID, then it will print on your file that you gave it the ID that corresponds to the file name. So let's look at the commands that you see here. We have 3 ways to input to display. So if I just have a value of x of minus 23.6 and I put x at the prompt, it will give me the result will be x and then equal, and then it'll skip a line and it will give me minus 23.6. If I say disp like display, and then you put in between brackets, square brackets, uh, and then in between hyphens, x equals, then it will write x equals. And then right away, without skipping a line, you put num to string x, then it will convert x, whatever it was, which is minus 23.6, to string, and it will print it as a string. So what you can see here is that we printed this whole thing here is a string, which corresponds to this command. A third way, which is more for like maybe large numbers or high precision, is to now use the formatted print on in a file, fprintf, but we don't have a file ID, so it means that we're going to print on the screen. And we give it the format, which is between hyphens, percent 12.6e. It means it has 6 decimals, and the total number of digits is 12, including the e and including the decimal point. So the 23.6 will appear to us, as you can see here, it will be 2.360000, like, because we have 4 zeros and a 3 and a 6, that's a 6 digits here, which is this 6 here. And then the total length is 12, excluding the negative sign. So this is excluded. So from here to here is 12, excluding the negative sign. So this is kind of the most common way of doing scientific output calculations, and we use it in general to generate the data and the results. So with this, I think we are in good shape now to finalize this area of